everyone, Teacher Jonas here, and today you're going to learn a new science topic, but it's super easy. You will see. But before we do that, let's review the last lessons we learned about forces. Okay, so the first topic we learned about forces was action at a distance forces. Now, as you remember, something happening is called an action. For example, you throwing a ball, or you running, or you pulling a box. These are all called action. Now, action at a distance, it means that something at a distance, it means that there is no touching, no contact. Like this one. If you can push the box from far away using magic, that is action at a distance, okay? But if you put your hand on the box and push it, that is not action at a distance because there is contact. Now, we're going to talk about forces that require no contact. It means it's at a distance. You see, these are two actions, two forces that require contact, that they need contact. Like when you push a box, when you pull a box, you see, you're touching it. So there is contact. It's not at a distance. Now, this is what happens when you do forces on an object. For example, you can change the state of motion. For example, you see a tire moving this way. You can boop, and then it goes this way. So you can change the direction. Or box at rest. For example, there is this little box here. It's not moving, but I do this. Whoop. Now it fell. It moved because I pushed it. I applied force. Next, force applied by hands on the dough changes its shape. You can change the shape of something using force. Okay, look at the shape of this, right? Now I do this. See, the shape changed. Another thing is that force change size of a rubber band. You can change the size of something as well. So these are the effects of force. We will talk about this more later. So look at this action at a distance force. You see, the apple is falling from the tree, but you don't see anyone pulling the tree or throwing the tree. This is happening because of one of these ones. Look at here. We have magnetic force, we have electrostatic force, and we have gravitational force. Gravitational force is the force called the attractive force exerting between two objects. What does it mean? It means that, for example, Earth is attracting everything towards itself. That is called Earth's gravitational force. So, this apple is falling towards Earth because of Earth's gravitational force. It's attracting everything towards Earth. That's why when I drop this, whoop, see, it goes down. It goes towards Earth because of Earth's gravitational force. Now, you see, no matter what you drop, it's going to go down like a basketball, like a tennis ball. When you drop it, it goes towards Earth because Earth is attracting everything because of gravitational force. Gravitational force. Now, guys, Earth and Moon go around each other because of gravitational force. Look at here. Moon orbits the Earth, goes around Earth because of Earth's gravitational force. If Earth had no gravitational force, Earth would just fly away. Now, the Sun has a very, very strong gravitational force. So strong that all the planets in our solar system orbit the Sun because of Sun's gravitational force. It's so strong, everything around it goes around it and goes towards the Sun. Okay, now, You can do this little experiment that I told you before at home, and you will see that everything you point, it goes towards Earth because Earth is attracting everything because of its gravitational force. Okay, next one is electrostatic force. Electrostatic force. Now, electrostatic force, I'm sure you have seen it. When you rub a balloon on your hair, you will see that it keeps attracting your hair. Like this picture, like this video. You see, this is because of electrostatic force. Now, electrostatic force examples are, for example, the comb attracting pieces of paper. You see, when you have a plastic comb and you have small pieces of paper, if you rub the comb on your hair, it's going to attract all the pieces of paper because of electrostatic force. Also, lightning striking Earth is because of electrostatic force. So remember, now we're going to talk about magnetic force. Magnetic force. Now, magnetic force is the force that comes from magnets. These are called magnets. You see, magnets attract metals, right? Now, magnets attract magnets too. For example, opposite poles attract. But if they are the same poles, for example, north and north, south and south, it's gonna repel. It's not gonna boop attract. It's gonna repel. Repel is like you push. So if you put north and north, it's gonna repel. Now, as you remember, we have these non-contact forces or action at a distance forces. It means that they don't have to touch. They can attract, they can push, they can pull something from a distance. Now, what type of force is this? See, Wile E. Coyote is falling down towards Earth. Earth is attracting him. So this is gravitational force. What force is this? Uh-oh. The TNT is made of metal, and the magnet attracted it. Uh-oh. So this is magnetic force. Now what about this one? Uh-oh. This is electrostatic force. It's kind of cute. Okay, so the next topic we learned was magnetic forces, right? So we learned about magnetic and non-magnetic. So let's review about this topic too. Magnets can be super strong, like this machine. They can be even small and still super strong, like these two. See, they're so strong that when they attract so hard that when they hit each other, see, they break. Oh, but we also have weak magnets, like these ones, like these toys. Okay, now let's see which objects will be attracted to a magnet. Boom. See, number one. Yes, because magnets attract magnets if they are the opposite side. Number two. Yes, these are made of metal. Number three. Paperclip. Yes, also attracted. Four. Plants don't have metals. They're not attracted to magnets. Five. A puppy. A puppy is not attracted to a magnet. Six. Flowers. Nope, just like plants. Seven. Other magnets. See different shapes of magnets. Yes, they are attracted to magnets. Number eight. These are made of metals. These screws are made of metal. So they are also attracted to magnets. Number nine. This needle is made of metal. Yes. 10, 11, 12. They are not attracted to magnets. Now, some metals are attracted to magnets. Now, you see, we have different materials. We have wood, fabric, plastic, ceramic. We have so many different types of materials. But only metals are attracted to magnets. But only some metals, not all of them. Let me show you. Metals like nickel. For example, this nickel knife. This one can be attracted to magnets. A cobalt coin, cobalt is also attracted to magnets. Steel spoon or steel paperclip, when it's made of steel, it's also attracted to magnets. Iron nail, iron is also attracted to magnets. Now, we call these metals, nickel, cobalt, steel, iron, we call them magnetic. Magnetic. Magnetic means that they are attracted to magnet. So, if something is attracted to a magnet, you call it magnetic. Now, we have these three magnetic objects, a spoon, scissor, a key, but it depends on what they're made of. If this key is made of plastic, it's not magnetic, okay? But if it's made of iron, for example, it is magnetic. Non-magnetic, crayon, bottle of water, it's plastic, right? This pencil, but if this part of the pencil is made of, let's say, iron, yes, it's gonna attract. Books. Nope. They are non-magnetic. Now, as I told you, not all metals are magnetic. For example, these metals are magnetic. Iron, nickel, cobalt, steel are magnetic. Now, here are some examples of non-magnetic metals. Aluminum, copper, lead, brass. These are non-magnetic. If you ever want to remember the magnetic metals, remember CINS. C, cobalt. I, iron. N, nickel. S, steel. CINS. Okay, guys, now let's talk about the new topic, okay? It's super easy. Push and pull forces. Push and pull forces. Now, as you remember, we have contact forces and non-contact forces. Non-contact are called at a distance forces. But today we're going to talk about contact forces. It means forces that come from touching something. So, a force is a push or pull acting on an object. Object, for example, this. This is an object, right? As a result of the object's interaction with another object. For example, my hand and this. Boop. This is a force. You see, I am doing something to this little candy. For example, forces can make objects stop or start moving, right? You see, right now, it stopped, right? And I make it start moving. Or if it's falling and I grab it, see, I stop the moving. For example, look at this girl. She's gonna hit the little ball. Let's see what happens when she does that. Boom. Now, what force was that? Did she pull the ball or did she push the ball? Let's see. Or look at this girl. This is a sledge. This is on snow and ice, right? She is pulling the sledge. Okay, so again, let's come back to this topic. Push or pull on an object is called a force. So push and pull are forces. Now, as I told you, you can change the state of motion. For example, as I said, let's say a ball is coming towards you, right? And then you push the ball towards another side. So instead of coming this way, now it goes this way. So you change the direction of the movement. Or a ball is stable, right? It's not moving. And then you hit it and it moves. So you can change its state. You can make it move because of force. You can change the shape like this one. See, I am pushing it in like this. So I change the shape. Or you can make the size different like a rubber band. You pull the rubber band and make it bigger. Look at here. Car being pushed by a man. See, he's pushing the car. Or this girl is pulling the chair. Now you may be wondering, teacher, what is the difference between push and pull? Push is when you add force, right? Like this, to an object away from yourself. Okay, this is me. If I move it away, it means I push that thing. For example, look at here. I do like this, right? I'm pushing it. I'm pushing it in like whoosh. That is called push. But pull is when you pull it towards yourself, right? For example, I have my phone here and I see it's coming towards me. So I am pulling my phone. Okay. Now, let's see some examples to make it clear for you. Pushes and pulls. Did you spot these examples of pulling forces? So, let's see some examples. Now, let's see. The rower pulls the oar. See, this is... Whoop, you don't do like this. No, you pull it towards yourself. I don't know if you have ever gone on a boat or kayak, but you do like this. You pull towards yourself. You pull these towards yourself. The tug of war team, see, they have one rope and they all pull it towards themselves. That's how they win. A catapult is pulled back. This used to be a weapon a long time ago. They put something here and then they pull it whoop, 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 back and then let it go. Whoop, it's gonna go. So they pulled it back towards themselves. The string of the bow. You see, this is a bow and arrow. You see, you pull this string towards yourself. So you pull it towards yourself. Or pulling the sledge. This is a sledge. You put it on ice and snow and you slide there. Now, people usually pull the sledge. It's fun. Now look at here. The bell ringer. Bring, ding, ring. You see, they pull it down and the bell ring, 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 rings. So they pull it down. So these are some examples of pull force. Next is push. Did you notice these examples of pushing forces? Let's see. The runner's feet push off the ground. When you're walking, when you're running, you're pushing the ground to walk. See, I am pushing to walk. That is pushing. Or a person pushes the keys down on a piano. When you play piano, you push it down. The hockey stick. See, she's a hockey player. She pushes the ball. Also a football player pushes the ball by kicking it. The golf club pushes. See, she is playing golf. You push the ball into air. Or the bat pushes the ball. If you play baseball, for example, you hit and push the ball, right? Or look at this little stroller. Oh, so cute. Mommy has to push the little cart, right? So she pushes it. So let's see. This girl, is she pushing or pulling the boy? Away from her. So this is push, right? This is push force. Now, is she starting movement or is she stopping movement? When she pushes, what happens to the boy? The boy moves. So it is start, right? It starts movement. Oh, very beautiful handwriting, I know. Number 2, when you do like this with a zipper, are you pushing the zipper or are you pulling the zipper? You are pulling the zipper. Yes, good job. You are pulling the zipper. Now, is it starting movement or is it stopping movement? It is starting movement. Very good. You start movement. 3. Oh, look, the boy is pulling the vegetable out of the ground. So he is pulling it, right? Pull. Now, is he starting a movement or stopping the movement? He is starting it. Yes, very good. Look at this man. What is he doing with the cart? Is he pulling the cart or is he pushing the cart? He is pushing the cart. Yes, so it is push force. Now, is he starting movement or is he stopping movement? He is starting movement. Yes. But if he is almost hitting someone, he has to pull it and he's going to stop the movement. But in this picture, he is pushing it and he's starting movement. Okay, number 5. What about this one? The ball is coming towards him, right? When he gets the ball, he has to push it away. If he pulls it, it's going to hit him in the face, right? So he has to push the ball to stop the ball, right? So it is push force. And is it to start movement or stop movement? It is to stop movement. Very good. Now, when you kick a football, what type of force can you use? What type of force do you use when you kick the ball? See? Boom! Imagine this is the ball. Boom! See, I'm pushing it, right? So I am using push force to start movement. But what about a goalkeeper? He has to grab the ball, right? He has to push the ball to stop the ball, right? Now we have different sports. See, can you describe other sports or activities that involve pushing or pulling? Yeah, many sports. When you play, let's say badminton, right? You push the ball up, right? Or if you want to stop the ball, you have to push it to stop it. So you have to push to start and push to stop the ball. So cool. So let's see. Now let's see this little example, okay? Pressing the button on the doorbell. When you press, are you pulling or are you pushing? You are pushing, right? You are pushing to ring the bell. Sawing wood. When you try to cut the wood, are you pulling or are you pushing? You are pushing. Very good. Brushing hair. When you're brushing your hair, are you pushing or are you pulling? You are pulling, right? You're pulling your hair. Now guys, if you go to some shops, you can see that the door has to be either pushed or pulled. Some doors open only if you push them. And some doors open if you pull them. So we have different types of doors too. Okay guys, that's it for today's class. I hope you learn new things. And stay safe, and until next time, teacher, join us out. Bye bye, everyone.